35. Lowest common ancestor of binary search tree. So we need to understand two concepts. So one is what is a binary search tree. Another is what is the lowest common ancestor, because this is very common. And we want to find the node which is the lowest common ancestor. So from Wikipedia we can know about what is the definition. Yeah, because there are special properties of the binary search tree. So for a binary search tree, so for this example, so this is the root node. So at the left side, all the nodes value gonna be smaller than 6. But at the right side, all the nodes value gonna be bigger than 6. As we can see, 2, 0, 4, something, 8, 7, 9, it is more than 6. So this is the property of binary search tree. And now we need to understand what is the LCA, lowest common ancestor. So for node 6, it is the ancestor of 3 and 5. It is okay, but it is not the lowest. The lowest is the node 4. Yeah. So from here, the lowest common ancestor is defined between two nodes. So this is P and this is Q. Between two nodes P and Q as the lowest node. So this is the lowest node in this tree that has both P and Q as descendants. So for this node 4, that has both 3 and 5 as its descendants. Yeah, this descendant means it is directly descendant. Yeah. So where we allow a node to be a descendant of itself. So for example, for node 3 and 4, the lowest common ancestor is going to be 4. Yeah. So if we understand what is the lowest common ancestor and what is the binary search tree, normally we can solve the problem. Yeah. Now let's just try to use the first example. For the first example, we have this P2 and 8. Yeah, so for P2 and 8, we're going to find the lowest common ancestor. And what's going to be that common ancestor? So it's going to be this node 6. And what is the property? So the property is this value. I mean, if all the node value is unique, so for example, this is 6, this is 2 and 8, always this would be unique. Let's check the definition. So as we should know, P not equal to Q, P and Q will exist, and all nodes value are unique. Otherwise, we cannot solve the problem directly. Yeah, because there are special definitions. All the nodes value are unique, and P not equal to Q and PQ exist. It means there must be a lowest common ancestor. Yeah. Now let's continue to check the first example. So for 2 and 8, we just need to check a value, maybe 6 or maybe other values, and this value gonna be less than the biggest value, which is 8, and more than the smallest value, which is gonna be 2. If we can find this value directly, so we're gonna return this node. Yeah. So for 2 and 8, if we find 6, we're gonna return this node 6 immediately. But what if P and Q is 3, maybe, yeah, let's just use P and Q is 3 and 9. Yeah, so which value we're going to return? Maybe you think this value 8 is also between 3 and 9. Why don't we just return this 8? No, we should not do that. Yeah, because according to the algorithm, normally we're going to use the pre-order traversal of the tree. If we are using the pre-order traversal, we can always find 6 first instead of 8. If we find 6 first, 6 is between 3 and 9. Of course, we're going to return this 6 instead of we're going to return this node 8, because 8 definitely is not the lowest common ancestor. Yeah. So we're going to use the pre-order traversal to solve the problem, and we're going to also consider the property of the binary search tree to solve it. Now let's just focus on solving the problem. Yeah. So we need to check the root value. So if root dot value is more than the maximum of P dot value and the Q dot value. Yeah. So this is for a root value. For example, we are going to check maybe 3 and 5. As P and Q. So P is 3 and Q is 5. Now we are going to find the lowest common ancestor. Currently it is 6. Yeah, so if this root value is more than P dot value and Q dot value, the maximum of them, if it is more than, so of course we're gonna go to the left, because go to the left we're gonna gonna find another value, maybe 2, and then maybe 4. Yeah. So we're gonna return self.lowest common ancestor with root.left with p and q. Yeah. So elif root.value, if it is less than the minimum of p.value and q.value. So what are we gonna do? So for example, our node currently it is p equal to 7, q equal to 9. So this is a p and this is a q. Currently, this is our root node. So this is less than 7 and 9, the minimum of 7 and 9. It means 6 is less than 7. So what are we gonna do? We're gonna go to the right. Yeah. So we're gonna return the right side. So the self.lowest common ancestor is gonna be root.right with p and q. Yeah. So if all the value, if my root value is between, so for example 2 and 8, so I'm gonna return the root directly. Yeah, because according to the question, I think I just needed to return the root instead of a root.value. So we're gonna find the lowest common ancestor node. As we can see, it is a node, it is not .value. So we're gonna return the root directly. Now let me just run it and check. So if so here I forget the so this is called comma. Yeah, I forget how to call it. I forget the 2 dots. So let me just run it. As we can see, it works. Now let me just submit it to check. Yeah, as we can see, it works and it's pretty fast. And the time complexity is because this is a binary search tree. So for each of the time, we just take half of the tree. So this is just log n time instead of O n. Thank you for watching. See you next time.